made it to this point, you probably want to see the code base for putting it together. And quickly, this is the principal architectural use model. Actors on one side, on the left, AIs and myself, devices on the right, an abstraction between the external modules, the command processor, and the message queue to allow a very loosely coupled association between them. The association is connected through the command event args, which is an implementation of the base event args with a couple added properties, and instructions that allow me to send more detailed commands of the conversation that I'm having with the device or an AI has with the device. You see that here specifically where I have recording that I want to start, but then I also have to add identifiers. You heard that when I said omega-1 as the identifier to start the recording. That's passed here. Also in playback, I need additional types of commands sent. Moving on to the next slide. Really, I had to consider in the architecture that the AI and myself through the Kinect input device would all be peers. And when I looked at it that way, I had to really think that all peers are the same, whether they're a human or they're an AI. They all communicate freely. They all have the same understanding of language semantics and the current context of the conversation. And they all have different behaviors, learning, and memory. Because they have different behaviors, that was implemented through a service factory, specifically through the factory interface here. So all AIs support this interface. A factory itself allows me to instance this specific service by instancing the AI under the interface. So this just simply delivers the class which connects to the service that I want. So here I use Skynet, but I can very easily instance the USS Enterprise service or the Whopper service. And you saw that I have those loaded up into the Azure Cloud as well. In case you're interested, the memento is put to use in the service. And so we'll see that here. If I bring up the service, in the logic, in that every time I get a command, because the controller sent, once the AI is instanced, every command is also sent to the AI. The AI may act upon it or not. But if I send a command to the device to take off, the device takes off, right? The drone does. But the AI is also included in that conversation. So here, those same command event args are getting sent. And here, if you looked at my service instancing, I have my own recording of all the commands that are occurring. That gives me the context for what's going on. In fact, I guess you could say that's my memento. You saw the factory pattern, service factory. Strategy really is the implementation of complex algorithms. In this case, I have an AI, which is a supposed AI, which is a very complex algorithm. This is the checklist of the things I needed to kind of build it. So I needed the right patterns. I had to have semantics for peer communication. I needed the Kinect input as a translator for what I did, voice and gestures. I need the hardware for the UAV and other devices, a big scalable platform. That's my Azure Cloud service. And then I need a central controller software. And that's essentially what I built here. The central controller, and I have it based on a form, and the form is simple, right? It's just a little device so that I could easily communicate the status of my current Kinect frame rate and what's going on. I'd say additionally, it allows me to easily thread with the UI for playing sounds to provide feedback. I found this really important in understanding what is going on. And it's kind of cool to have the computer talk back to me in the voice of the USS Enterprise. So the form only does a couple things. If we look at the code base here, really we instance the Kinect processor, and we establish an event listener for Kinect to send me stuff. It's important to know I throttle the events out of the Kinect processor because it just sends a lot of things, and I'm only interested in a few of them. So I do a lot of processing inside there to only send me what I need, not everything. All right, and then the helper class is really where the logic is executed for sending those things. So here I have an AI changed event. Here's the user's actions. If my label is coming in, if my information is coming in the wrong thread, I use a simple looking at a label to see if it's on the wrong thread. If it is, I call it delegate to call it back on the UI thread. Very simple. I've got a simple frame counter, tells me the status, and then I go through and start executing logic for what does Skynet do? Am I making a recording? Am I sending commands to a specific drone or not? All right, so this is got the Azure service up. You guys saw that in the code. All right, in conclusion, you have a choice in publish subscribe or an asynchronous request model. Almost in every case, you'll use publish subscribe, right? Especially for AI, so they can freely communicate. I guess this one's a little plea for if anybody's got a real AI out there for me to connect to and use, I'd love it, you know, please. I'd like to add a bunch more devices. So far, I've only 3 that I've tested, but I can use them all at the same time. It's working well. Kind of looking into the future, you could go for an implanted cranial device to send communication to your AI. That's kind of cool. I think I might do another prototype to directed devices by phone. Under its current model, because my AI is connected to my controller, my phone can connect to my cloud service and give it commands, and then the cloud service can choose to send it on to the controller and to the device. This is a very straightforward model, only adds an application for the phone to connect to the service, which is fairly common. Okay, a couple references for you, and thank you for your time.